Hi everyone, I'm Miss Felicia teaching from OVERMUGGED Bukit Timah outlet today. Yep, so for the lesson today, maybe I just give you a brief overview of what you can expect for today. Okay, so for the physics lesson today, which is lesson number 2, so if you have missed lesson number 1, you can actually follow OVERMUGGED O-level Telegram channel. So you just go to Telegram, there's a search bar, just search for OVERMUGGED. So if you want to watch like the lesson number 1 recording, it will be made available soon. Yep. Or else you can also check out the website, see whether like, is there any more like physics session 1? Yep. So session 1 and session 2, the topics covered are different. So for session 1 back then, I actually covered mechanics. Yeah, so for today's session 2, we will be covering on thermal as well as light. Okay, so just to share a little bit about OVERMUGGED in case you have never heard of this tuition center before. Yep, so we are actually a group of specialist tutors, and the teachers here are actually all very young and dynamic, so they're like, we can like click in with you all. Yep, and that we mainly teach secondary school and JC. Yep, so we cover classes in the O-level, IP, and A levels. Yep, and that all teachers here are actually all uni graduates with at least 5 to 13 years of teaching experience. Okay, so for OVERMUGGED, we actually have these 3 branches. So if you're interested to collect like any of the subjects of OVERMUGGED's revision kit, yep, so you can actually head down to Bukit Timah Center or Parkway Center or Serangoon Central to collect your revision kits. Yep, so the revision kit comes in mainly 3 main subjects, which is English, the math. So we have like A math, E math, POA. Then sciences, we have triple pure science and triple combined science. It means all sciences are covered. So if you want to get a copy, it is only distributed in hard copy. It won't be shared in soft copy. Yeah, so you have to come to the center to collect. Yeah, or you can just sign up for any of the physical lessons, like the end of year revision lessons. There's still some more lessons upcoming, yeah, over the next few days till the end of the week. Yeah, so if you just attend a physical lesson, you can also like at the same time, yeah, you can collect the physical copy too. Yeah, but if you find that like this is like insufficient and then you want like the more in-depth notes, you can actually purchase from OVERMUGGED website, yeah, which is like $40 a book for the original copy that we use during tuition class. Yeah, so this is actually just the extract of it, which is like the essence. Okay, then besides the 3 centers, we also teach at elsewhere. Yep, so these are the spaces that we teach at. Yeah, so we also do teach at Toa Payoh, Jurong East, Woodlands, and then up and coming, it will be Tampines. Yep, so just to share a little bit with you all about myself. So this is my name, I'm Miss So the subjects that I teach is mainly O-level and IP. I teach all 3 sciences, Chem, Physics, and Bio. That's why today I'm teaching you teaching you Physics. Yep. And then here's my track record. So generally, most of my students actually fare very well, yep, throughout the years. And some background about myself. So I'm actually an NTU graduate. I graduate from major in science, and that I've been teaching both IP and O-level, upper sec and lower sec all 3 sciences. So before I joined OVERMUGGED, last year, I was at the other tuition center called the Learning Lab for the past 7 years. Then before that, I was in another tuition center called Wasteland. Then I also did like many like MOE relief teaching too. Yep, so here's my classes. Like this was like the photo taken at like National Day here at the Bukit Timah outlet. Yep, then yeah, so usually for OVERMUGGED, we are the kind that like we very treasure students' welfare. Yeah, so like as and when we order like that, this is like bubble tea, koi, and then sometimes we order pizza, KFC, McDonald's. Yep, so we'll always like order it like once a month or once every few months. Yep, then for all lessons here is actually there are actually free snacks. Yeah, so for those who are physically present here, later if your goodie bag snacks not enough, you can go over to the cupboard outside there. You can feel free to take the snacks. Okay, so then, so what will we be doing today? So for the lesson today, we will be mainly going through the key points of each chapter. So if you look through today's lesson material, it's actually mainly like notes, summary, then we try the question. Then notes again, then try the question. Yep, so to go through with you the key concepts, as well as I will also be pointing out what are the common misconceptions that your friends might have made. So today you learn and then you don't make that mistake in your exam. And that there will be guided step-by-step instruction for the difficult questions. So for today's worksheet, the difficult ones, I'll go through with you to guide you on how to tackle it. Then for the simpler ones, I'll let you try it out on your own. And then for questions that you try on your own, if you did not do it during lesson time, no worries, because at the end of the lesson today, I'll be providing you the answer key. Yeah, so actually for this material here, I purposely put in way more question than what we can cover in these 2 hours, because it's meant to like purposely give you like some extra practice question so that you can go home and like do some more self-practice. Yeah, since like 2 hours is definitely not enough. Yeah, so you should practice some at home. And then the questions that we have picked are mainly the commonly tested questions, the staple questions that often appear in end of year exam. Yeah, and today I will be also teaching you, especially like for the thermal topic, like the conduction, convection, radiation topic, there will be actually standard answering like phrases, answering templates. Yeah, so once you memorize that template, you write it in your exam, right? You will be able to hit all the keywords that teacher requires you to write, then you can get full marks already. Yeah, so there are some chapters that you can actually like get full marks for, even for explanation answer. Then lastly, later, we will be actually practicing some of the commonly tested questions. Okay, so let's make the most productive 2 hours ever. So let's begin. Okay, so for those who just came in, just a repeated announcement again. So for the lesson material for today, you can actually scan the QR code to download it, or if you want to, you can also download from the link that I've just sent it into the Zoom chat. Yeah. So please make sure you have a copy that you can write on. So just to let you know that for my teaching style today, make sure you follow this, okay? Whenever I highlight or I write anything on the screen, you follow and note it down in your copy. That means my copy should be the same as your copy. Okay? Okay, so we'll start off with thermal topic first, because for thermal topic, all schools need it. But then later, when it is on light and wave, I will then split you up. So that means if your school only do thermal topics, the full 2 hours, you will just do thermal topic. I will give you further instruction. Then for those of you who school do light and wave, you just continue to listen to me when I teach. Okay, so let's begin. Let me make it bigger. Okay, so for the first thermal topic on kinetic particle model of matter, so mainly you need to know about this thing called the Brownian motion. So Brownian motion is actually an experiment where they actually show you that the particles, they will actually like move like in like random manner. Something like that. Yep, so maybe can you all draw in this diagram? So this diagram is actually seen under the microscope. Yeah, copy down. Yeah, so you see that they will just anyhow move. The arrow here, right, there's no fixed way of drawing, okay? There is no need to follow my drawing. You just make sure that the lines just zigzag, and then whenever they change in direction, it's always like a sharp edge will do. Then it should be one continuous line. Any direction, doesn't matter. Okay, then next, need to know that what is inside? Yeah, what are you looking at? So you need to know that this big one over here, it can be in maybe the form of pollen grain. Yep, so if this big particle here is pollen grain, then you need to know that the corresponding background particle, it will be water. Yeah, because when you put pollen grain in water, it will be able to float around and then it will move around. Okay, then next is that for the particle, if it's not pollen grain, another way is that it could be like dust particle. Yep, so if it is dust particle, then it will be suspended in air. So take note that it must be the correct match, okay? That means if it's a dust particle, the background should be air. Because if dust you put with water, isn't that like you trying to like wipe off the dust from like your table or your furniture? So if dust is contact with wetness, then it won't be able to move anymore. Yeah, so only if dust is in air, then maybe like like haze and all, yeah, then it will then be able to move around. So mainly is that we want to see them undergoing this constant random movement. Okay, maybe I highlight in another color. Yep, so can you follow me and highlight it? Okay, so then then next is that over here you need to know what's going on, like how come there is like this kind of sharp edges. Can you see all these like sharp edges? So what is going on over here? You need to know that this is due to uneven bombardment with the surrounding particles. Yeah, so why they change direction is because in the background, you cannot see it, but it's present. There are actually some other particles. That's why when the pollen grain collide onto it, it changes in direction. And then next is sometimes question they will ask you, how come you can see this pollen grain? But how come the background, which we said like collide into water or air, how come we cannot see them? Mainly is because of the size, not the color. Okay, so let's highlight it. Yep, so it's because they are invisible. So talk about the size. Okay, so mainly is that invisible. Why? Because they are small in size. Not about the color. Yeah, so how come it's invisible? Because it's too small to be seen even by the microscope. Yeah, I think you can sort of visualize, right? Like for example, water. Water is just H2O. Isn't it very small? It's just 2 hydrogen and 1 oxygen atom. It's really very small. As compared to pollen grain. Pollen grain is like really huge. You can see with your naked eyes also. Yeah. Okay, then so in this diagram, what are they trying to show? They are showing you that smoke particles move continuously and randomly. Yep, as they are being hit by unseen, fast-moving background air molecules. So remember, whenever it is like smoke or dust, okay, smoke or dust is around the same. So maybe I write it together. Yeah, smoke and dust, it should be suspended in air. That's why it is collision of smoke with air. Then the reflection of the light from these big smoke particles, yeah, it will appear as like the bright specks. That's why you will be able to observe them. Okay, so for this topic, it's all about sentence writing, right? So how do you like explain so that you can like get full marks for the explanation answer? So here is the answering technique. So whenever question is asking you like, they ask you, why particles are moving constantly in terms of Brownian motion? And then this will be the model answer. So if you write this, then you can get full marks. Okay, so then for the blank over here, you fill in the blank according to the context of the question. Yeah, so if the question show you pollen grain, you write pollen grain and water. Yeah, so keywords you need to have will be that they are constantly and randomly bombarded. That's why the direction that they move is like anyhow, because it's randomly bombarded. Okay, so I shall move on. You all should be done copying by now, right? So for those online, if you are not done copying, maybe can you take a screenshot or you take a photo of it? So I will be moving on in 3 seconds. Okay, so counting down, 3, 2, 1. Okay, moving on. Okay, so then the next common kind of question that they will ask will be this. Like, how does gas particle exert pressure? Because gas, mainly is because gas keep moving. And then if you keep moving, you keep on hit a surface. Isn't that force exerted per unit area? So force per unit area, that is pressure. Yep, so that's why mainly is because the particles keep moving and then they constantly bombard. So when they constantly bombard, there will be the force per unit area, which is like what I mentioned. Yep, so can you follow and highlight the key points? So that's why when there's a force exerted per unit area, this is pressure. Yeah, so this is like the nice template. Once teacher asks you this question, you just copy and paste, then yes, full marks. Okay, so done with the summary. Let's now take a look at some practice questions. Okay, so for the practice questions over here, these are MCQs. So MCQ is like easier. I'll leave it to you to try on your own. So we take a look at the open-ended ones. Yeah, because open-ended is like, harder to hit all the keywords needed. So I'll guide you for this. Okay, so for this question here, they ask you to explain in terms of air molecules, how the air inside a car tire exerts a pressure on the walls of the tire. Okay, so by looking at this, can you now take a look at the notes? Do you think if there is any like of the paragraphs here that we can like copy to be the answer? Is there? Or we need to write out on our own? What do you think? Can copy or should we write out on our own? So how? Can copy, right? Which paragraph? This paragraph, can? So this is the answering technique that you see, that's how you can apply answering technique. Yeah, so you also need to be able to recognize that like, oh, after you memorize the answering technique, whether can use or not. Okay, so maybe let's write it down over here that this is the answer from the last answering technique. I shortcut, okay, AT for answering technique. Yeah, so maybe can you label it, then later you write it in on your own, then mainly is to see whether can you fill in the blanks correctly or not. Okay, so can you write down the hint? Yeah, refer to the last answering technique. Okay, then I shall move on to the next question. Done labeling, right? Okay, so those who are not done, if you're still busy downloading the lesson material, maybe you want to take a screenshot because I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so then for the next question over here, question 5. Figure 5.1 shows an illuminated smoke cell to demonstrate Brownian motion of smoke particles in air. So part A, they ask you to draw the movement. This one, I let you draw on your own at your own time. Okay, I go through the more difficult ones. Part B. Explain using concepts of molecules why the smoke particle moves in the pattern drawn in part A. So same thing again. Can you check back the front page, like the answering techniques? Is there any like answering techniques that we can use in the first page over here? Is there? So they are asking you why the smoke particle move in the pattern drawn in part A. So how can you use or not? Yeah, can use, right? Which one is it? The first one. Isn't the phrasing kind of similar? It's also asking you to explain, which is why it move. Yeah, then move like constantly. Yeah, so this is actually the answer. But if you notice, this is only one liner. But for our part B, is actually 2 marks. Okay, so maybe first, why not you copy down the answering technique first? So this will be the first 1 mark. Later, I guide you in how to answer the second mark. Yep, so you all fill in the blanks first. Can you write this in to your answer for part B? Yep, write this into your answer for part B. We more or less done copying. If you're not done, you just refer to your notes. Then I change the page. So then, yep. So now let's check whether like have you filled in the blank correctly. Okay, so I will just copy and paste from the notes there. Okay, so for the first blank over here, this time round, it will be not dust, gas, or pollen grain. Obviously, this is smoke particles. So you just phrase it according to the question. So the answer is smoke particles are constantly and randomly bombarded by what particles? Air, correct. Okay, so then this is 1 mark, but then need the second mark. So that means you need to further elaborate. Yep. So then they are asking you in the pattern that you have drawn. So the pattern you draw is the the anyhow pattern, right? Yep. So mainly is that why is it anyhow? So mainly is that because when they bombard, it will be at different. Then some lines you draw are longer, then some lines you draw are shorter. So what do you all think is the blank over here? By the way, for my lesson is that you should attempt to answer me, okay? Because if you answer me, if wrong, I will tell you the correct answer. But if you don't answer me, I will also just continue it for you. So how much we can cover today will also be how responsive you are. Okay? So for the first blank over here, so it's like mainly is that when you bombard, you will be always bombarding in different directions, correct? And then when you draw the lines, some are longer, some are like shorter. So mainly it's because it is moving at different speeds, correct? That's why causing it to, can you just answer back the question? Causing it to move in a so what kind of manner is it moving? What is this? Correct. Constant and random. Yep. So you write constant also can. Another one you want to write is that you can write continuous also can. Both means the same. That means it just keep happening. Okay, so moving on to part C. Use ideas about molecules to explain how the air inside the air cell creates a pressure. So same thing again, can you check back the answering technique? Do you think if there is any like of the answering techniques here that we can use? Is there? Have or not? Have, right? Which one is it? The second one. So you do realize after you practice a while, like the question tested, like even from different schools, like you see here, this is like from Bedok Green, then this one is like from East Spring, like different school, the question style kind of similar. You tend to be able to use back like the similar answering technique. Yep. So then you just copy the second answering technique will do. Okay, so can you like label it? And then I leave it to you to copy it on your own. Yep. So you just label down the hints. Okay, so I shall move on. Should be done copying by now. So for those online, if you are not done, can you take a screenshot? I'm going to move on in 3 seconds. 3, 2, 1. Moving on. Okay, so moving on to the next chapter, it will be thermal processes. So for thermal processes, mainly it's about the conduction, convection, radiation is like the main bulk of it, right? Okay, so how do you distinguish, like, maybe I give you a question, is it conduction or is it convection or is it radiation? So how do you tell? So mainly it will be by this. So for conduction, mainly you check, is the heat source and the object, are they in contact or not? So for example, like if I see that my hand has like, some heat because I'm hot-blooded, right? Warm-blooded. So if I touch like maybe a metal rod, I'm able to pass the heat from my hand to the object. So when my hand is touching, this is called conduction. But if it's like the fire, like campfire, then you stand at a distance away. Since I am not touching the fire, but I can feel the heat from the fire, that is not conduction already. That will be something else. And that is actually radiation instead. Okay, so that's one factor that you can differentiate. Second method is that you go by the states. So for conduction, it can take place in solid, liquid, and gas. So if it's solid, so in a way, once you know that it is solid, you can kind of eliminate convection already because convection don't happen in solid. Okay, then what else? I think mainly that's about it. Yep, like that. Okay, so for conduction, also need to know who are like better and poorer conductors of heat. So it will be this. Let me just double check. I didn't write below. Yep, correct. Okay, so mainly need to know that for conduction, right? Conduction, it will be poorest is actually gas. Yep, so can you follow me and note it down? So poorest will be gas, then followed by liquid, then solid will be the best conductor. And then solid, you can also further differentiate it. Non-metal will be a bit poorer. Metal will be the best conductor. So this is for conduction. Because later, right, for convection, it will be opposite. So let's fill in convection in advance first. So for convection, make sure you are copying it down. Yeah, copy it in. So for convection, liquid will be poorer. Gas will be better. Oops, no space. Poorer. Maybe let me just rearrange my words a bit messy. So this one is liquid is poorer in convection. Why? Because for conduction is actually one particle vibrate, then they will collide to the next particle vibrate, collide to the next particle. The particles keep passing down the collision. So that's why if your particles are closer together, it's easier for you to pass down the collision. That's why for solid, it will be best in conduction. As compared to gas. Gas is like very far, but if one particle vibrate, it might not even pass the vibration to the other particle. That's why you can't transfer the heat that efficiently. Okay, then next it would be liquid. Sorry, next it will be convection. So for convection is the other way around. Why? Because for convection, it would be that hot rise, cold sink. So for gas, you should know even from chemistry, kinetic particle theory that gas particles are always in constant random motion in high speeds. They are always moving continuously at high speeds. That's why since gas can move faster, that means they can rise faster. That's why for convection, gas will be better, but conduction, gas is the poorest, directly opposite. Okay, so now let's take a look at how to apply these answering techniques to write in explanation answers. So if the question is asking you that is like maybe why do we tapao food in like styrofoam boxes? Then how do you write? So mainly is that for especially for a few of them, which is styrofoam and fur or feather of animals, take note that you don't directly say that styrofoam is a poor conductor or feather is a poor conductor. No. Only for these three, make sure that you mention that they trap air. So this is one of the common point that usually students never write. Yeah, a lot of students will jump straight into, styrofoam is a poor conductor. So take note that you must mention that styrofoam, feather, fur, they trap air. Then air is a poor conductor. Okay, so then, so then you fill in the blank. Air is a poor conductor of thermal energy. Take note that now that you are in upper sec, right, don't write heat energy, okay? So take note, heat and energy, right, you take it that these two words are like enemies of each other. You cannot put them side by side one. So if you want to use the word heat, can. You tell me like, oh, gain heat, lose heat, okay. Because as long as the word heat and energy not together, it is all right. Just don't put heat and energy together. You can use heat still, but don't say heat and energy. So if you want to write it in the form of energy, can you write it as thermal energy instead? Okay. Okay, then next is that you just continue to copy the sentence. So it helps to reduce. Then you see your question. Are you trying to gain heat or lose heat? So for food of course we don't want it to lose heat, right? So that your food can remain warm. Then when you eat, then more delicious. So that's why it should help to reduce the loss of thermal energy. So maybe you can this time around fill in as loss of thermal energy from the food to the surrounding by conduction, allowing the food to stay warm, something like that. Okay, so the blanks I purposely left it blank is because it's for you to fill in the blank according to the context of the question. Okay, so this is just asking you in general, like this material, like what you use. But if question were to ask you like maybe explain in molecular terms or explain in terms of molecules, then how do you write? So generally for non-metals, they are poor conductors. So this will be how you write your sentence. It's like, oh, as one end of the maybe like the plastic rod is heated, the atoms at the end will gain thermal energy and vibrate faster. Remember, I mentioned to you that how heat is being passed down is mainly by vibration. Then they will collide with the neighboring atoms, then transfer the energy to them. So when this energy is transferred, it will be actually also thermal energy that get passed down. Okay, so then done for poor conductors. Next, we also have answering techniques for good conductors. Okay, so I'm going to scroll down. So if you are not done copying, can you take a screenshot? I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so for good conductors, so same thing again, like maybe if they ask you like why cooking pots and pans are made of metals, then you just fill in the blank that metal is a good conductor, so allowing greater rate of thermal energy gain from like the fire to the metal pot. Then this part here actually also depends. If it's just a 1 mark, then you can just say until here enough already. But if they need a little bit more explanation, then you might want to include a little bit about like what kind of molecules involved. Like this time around will be not only the atoms plus the electrons also. Then like allowing the pot to become hot faster so that you can cook the food faster. Then likewise also, if they give you in terms of molecular terms, they just copy the whole answering technique. But this time around, besides the atoms, there will be additional free electrons. Free meaning free moving. That means the particle can move around freely. That's why the electron can move from one end to the other end very quickly because electrons are very tiny as compared to the size of an atom. Okay, so maybe let me just show you this video. Yeah, let me just wait for the advertisement to end. I'll just show you the main section. I'm not playing the whole video. Okay, so key point that I wanted to show you is that if it is like non-metals, Okay, I'll just voice over it lah. So if it's like non-metals like glass rod, it will be one particle vibrate, then collide to the next, then that collide until you pass on the thermal energy. So generally for non-metals, heat transfer is slower. As compared to metals, the metal rod, because the electrons are very small, it is able to like zoom past and then reach the other end very quickly, transferring the thermal energy to the other side much more quickly. And so this is why metals are better conductors of heat. Okay, so moving on, next it will be convection. So for convection, let me just address the question that someone raised in the group chat. I can't undo my drawing. Okay, never mind. So someone actually asked about the convection in solid. Take note that just now when I was drawing my arrow, there isn't an arrow that is extended out from solid. Convection only takes place in liquid and gas. Yeah. Okay, so moving on to convection, it will be more straightforward. It is just like that. Yep. So mainly is that the first sentence you must cover 4 main points. Number 1, you tell me in terms of like the heat or temperature. So maybe if I say that I have a Bunsen burner heating up a substance, then you should use words like gain thermal energy. As compared to the second sentence, you tell me like cooler. Second one, it would be the word like expand or contract, but take note, okay, only the first sentence have the word expand. Second sentence, don't write contract, okay? Why? Because if I have a Bunsen burner can't contract anything. When its Bunsen burner is hot, so that's why it should be expand. You don't write contract, okay? Then the third point you should write is about the density. Then the last point is about the movement, rise or sink. Okay, so anyways, to cut short your answering technique, maybe this part you can cancel lah. Don't need this place. Just say that the denser, like maybe air or denser liquid at the top sinks to the bottom will do. Then a key point need to have would be you're producing a continuous convection current and that the process repeats itself. So take note, okay, that first and second sentence mainly same key points, the same 4 key points except the word expand or contract. So that means only if it's hot, you write expand. Cold, you then write contract. So maybe if I were to say that maybe if it's in an aircon room or maybe like refrigerator or freezer, then you write opposite. So if it's freezer, then you say that the air inside the freezer loses thermal energy, contracts, and become more dense, causing it to sink. Then the warmer, less dense air at the bottom rises to the top and in turn get cooled down. Then you copy the rest. Okay? So that means if it's like cooling, like aircon, fridge, you just directly just switch every word to be the opposite direction. Yeah, like that. Okay, then so for convection, same thing also. If I give you a question, how can you tell that it's a convection question? So number 1, you go by the states. It is only possible in liquid and gas. And that the most iconic thing is about it being always hot rise, cold sink. So this is the direction. As compared to radiation, radiation is not so vertical because convection is rise and sink, it's very vertical. But for radiation, it will be in all directions instead. Can be up, down, left, right, front, back, diagonal, sideways also can. So for if it's in any random direction, it will be radiation instead. And then next is as compared to conduction. Conduction, I must touch the heat source, right? Like for example, like in the kitchen, if like anyone cooks in the kitchen, the pot touching the stove which has fire. So if the fire is in contact with the pot, that is conduction, because got contact. But if it's at a distance away, that will be radiation. Yeah, so this will be something like campfire at a distance away. Yeah, so can you copy it in? At a distance away. Then next is for radiation. It will be also very fast compared to conduction and convection. So sometimes they will to ask you maybe, can you identify the main mode of heat transfer? Main, you should write radiation, because if got radiation, you try to write radiation because radiation is very fast. It's actually at the speed of light, which is super, super fast. Okay, then next is that for radiation, it usually the common examples they will test, it will be like sun or like fire. Usually you see like suntan or like fire, then you should choose radiation. Okay, so then for radiation, how do you use the answering technique? So mainly is that you must identify, like maybe if I say, oh, black surfaces. So you can say, oh, black, is it better or poorer? I'll go through with you on the next page. Then is it absorber or emitter? I'll also go through with you on the next page. Then like what surface? Then, sorry, over here, can you update it? That instead of saying more or less, you should say that it should be a greater or lower rate of thermal energy will be gained or lost. Yeah, then tell me the direction is from where to where. This will be better lah. Yeah. Okay, so done. Okay, so once you are done noting down everything, can you okay, I think I will just move on. If you are not done, then maybe you take a screenshot. I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so then yeah, as I mentioned, I want to go through more with you in detail, right? Like how do you know if it's better, poorer? Is it absorber, emitter? Is it on the next page? Oh, don't have already. Okay, I think because my notes, I cut it very short to summarize the key points. Okay, so maybe let's write it down at the bottom. So mainly there are 4 factors affecting radiation. If you have post-it, you can use a post-it also. Okay, so mainly I'm going to write down the 4 factors that affect radiation. So first, it would be the color, then the texture, then the surface area, then lastly, the temperature. Okay, so for better in terms of radiation, do you all remember, should it be bright color or dark color to be better? Can you remember? Have you studied? How? Is it dark color or bright color to be better in radiation? Yep, thank you, Zach. Yep, it should be dark color. Then poorer, it should be bright color. Okay, so since this topic, you also learned it before in school. So instead of me explaining, why not I test you instead to see whether you understand or not? Yep, so maybe for example, if I'm at the beach, so it is very hot, right? So if I'm at the beach, usually what is the color clothes that people will wear so that, you know, like they won't be too hot? Because at the beach, like no aircon, no fan, and very hot, right? Yeah, so usually what color do people wear? Dark or bright color? People usually wear bright color, right? Yep, correct. So why do people wear bright color? Of course, there will be some guys that like, you know, try to show off their abs and purposely topless. Okay, so assuming that we are the shy kind, then we still wear shirt. Yep, so by right, we should wear bright color shirt. Okay, so why is it bright color? So in this case, if we say bright is poorer, so should I write poorer absorber or poorer emitter for my shirt color here? Do you all know? Very good. Poorer absorber. Why? Why do we choose absorber and not emitter? Because you have to recall the definition of heat flow. Heat always move from high to low temperature, correct? So in this case is that at the beach, I very scared hot, then I scared I sweat. Yeah, so that's why mainly is I scared that I gain too much heat. Because only if I gain heat, then I will sweat, correct? So mainly is that I want to choose a color that is a poor in absorbing. Because surrounding is very hot. Yeah, I don't want the heat to be from the surrounding to enter me. Yeah, so that means in this case, heat always move from high to low temperature. So that's why heat should move from the surrounding into us. So that's why it must be an absorber. So since definitely is absorbing, choose a poor absorber color. So that's why in this case, we should wear bright color clothes. Okay, then now let's go to the opposite scenario. So maybe now, for those online, maybe if you are in an aircon room, and then for those physically here, you are in like the tuition center is aircon place. So maybe it's like very cold. Okay, so now in this case, if you are the kind that, I'm very lazy to bring jacket. So maybe can I just like wear clothes that is like long sleeve, then like I wear the correct color, and then hopefully I don't feel very cold. So in this case, this long sleeve shirt that I wear, because I lazy bring jacket, what color do you think I should wear so that I won't easily shiver? So what color do you think we should wear? Then you don't feel cold easily? The answer is opposite. It's actually bright color. Shouldn't be wearing black. Surprise. Why is it not black color? Okay, the reason is because same thing. Always look at how heat flow. Heat always move from high to low temperature, correct? Yep, so that's why our body usually is about what? 36 degrees Celsius, no fever kind. Then aircon usually like, like 20-ish, maybe 22 degrees Celsius, just 20 something degrees Celsius. So how does heat flow? Heat always move from high to low temperature, right? So in this case, we are emitting heat out. So if you're emitting, and then I said that I don't want you all to shiver. So if don't want to shiver, that means I should emit out slowly. That's why it should be a poor emitter. Then poor is bright color. That's why the answer is that you should wear bright color clothes. Okay, so that you'll be a poor emitter of infrared radiation. Yeah, so how to remember? You just based on, actually, if you look at these two scenarios, you all wear bright color. So black actually, right, it's just to act cool only lah. So it doesn't help you whether you go to hot place or cold place, okay? So whenever you go, wherever you go, just wear bright color. That will be the most ideal. Okay, black is just to act cool only. But of course, black has its own use also. Like for example, like cooking pots and pans. Because cooking pots and pans is, I want to gain heat fast. So that's why, of course, you should choose black, because black is like better in like absorbing the heat. Okay, so then, yep, so this is for colors. The next one, it will be texture, the shiny versus dull. Yep, so in this case, for the shiny, it should be the poorer, then dull, it should be better in terms of radiation. Okay, so in this case, let me test you again instead of me going through with you. So like for like aluminium foil has two sides, right? Got the shiny and the dull side, right? Okay, so now assuming that I'm trying to draw, sorry, I know my aluminium foil very ugly, but okay, but this is an aluminium foil. So can you take it as there's an aluminium foil, then you wrap around some food. Yep, so can you draw this in? So I have food, then aluminium foil wrapping it. Okay, I'm trying to draw like, like got two sides. Okay, so can you draw in the aluminium foil wrapping the food? Okay, so in this case, whenever you go maybe like BBQ with your family members or like or friends, do you know that which side should touch the food? Is it the shiny side that should touch, or is it the dull side that should touch? Do you know? Is it shiny or dull that should be touching the food? Or you're just anyhow? Very good. Yep, Z is correct. Yep, it should be the shiny side that should touch the food. Why? Because for shiny, mainly is that it will help to be able to reflect the heat back onto the food. Okay, so that's why shiny is so that it will be a good reflector, as well as it will also be able to be a poor emitter also, because heat always move from hot to cold place. So if my food is like very hot, by right I want it to stay warm. But the thing is that because you are exposed to surrounding, so heat might escape to the surrounding. So now we are trying to not let the inner surface here to emit out the heat. That's why you should actually choose dull, which is, choose shiny, so that it will be a poorer emitter, so that you don't emit the heat out. Sorry, you can see the word emitter. E-M-I-T-T-E-R. Yeah, poorer emitter, so that it doesn't emit the heat out, so that the heat can continue to be trapped in the aluminium foil to continue keep the food warm or to continue to cook the food. Okay, then next, for the exterior surface, it would be dull. Why? The reason is because for the exterior surface is that usually is where your heat come in. Like example, you want to do some oven baking of the food, or like maybe BBQ. Yeah, so if it's BBQ, like the fire will be like at the bottom, right? Yeah, so if you have fire at the bottom, then in this case, you want this external surface here to be able to absorb the heat fast, correct? Because this is the surface where the fire is exposed to. Or if it's like oven, it's like from the surrounding. So best is the exterior surface absorb my heat faster. Then I can cook my food faster. That's why it should be a better absorber. That's why in this case, yep, it should be better. So that's why down surface should face the outside. Okay, so next time if you go BBQ with your friend, I don't think you will be able to think of what did Miss Felicia say during this free revision lesson. Should it be shiny or dull? I don't think I have time to go and process my physics thinking. So to make it fast, if you are out having like trying to wrap food using aluminium foil, you just based on this. You know, food usually we want to keep it clean, right? So to keep it clean, which side looks cleaner? Is it the shiny or the dull side? The shiny one feels cleaner, right? Although you know both sides are equally clean. Yeah, so that's why you put the shiny side to touch the food. Then in this case, you will feel more like cleaner the food. Okay, so that's the fast way to remember. Yeah, some tips and tricks that we teach at tuition. Okay, so then moving on next, on the next two, I think very straightforward. Of course, if you have a bigger surface, radiation will be faster. Smaller surface area, of course, is slower. If it's higher temperature, of course, you can emit the heat out very quickly. If it's low, like lukewarm that kind, then maybe yeah, it's like emit heat out very slowly. Yeah, like that. Okay, then last thing to take note is that whenever you use the word better and poorer, take note that whenever you talk about absorber or emitter, so that's how you decide is based on is it gain heat or lose heat, right? So when you write absorber and emitter, make sure that you write with the word infrared radiation. If you write absorber or emitter of heat or absorber of or emitter of thermal energy, that's wrong. Why? Because absorber and emitter are words that you only use in radiation. Do you realize that in conduction or convection, we don't use like absorb, emit, right? We only use gain or lose. Yeah, so that's why absorber and emitters are words unique to radiation. So you should use the word absorber or emitters of radiation. If your school teacher didn't use the word infrared, then you can skip infrared, you just write radiation. But no matter what, you shouldn't be saying absorber of thermal energy. That's wrong. So thermal energy, when do you use it? Over here. When you talk about the gain or lose. So whenever gain or lose, we will use the word thermal energy. Because even in conduction and convection, we also mention gain lose thermal energy, right? Yeah, so that's why gain lose is with thermal energy, not radiation. So need to match correctly. Yeah, match correctly. Done. That's all for radiation. Okay, so I shall move on now. So if you are not done copying, can you take a photo or a screenshot? I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so over here, same thing for the MCQ. I'll leave it to try out on your own later. Okay, so let's take a look at the more difficult ones, the open-ended questions. Okay, so for this question here, they said that figure 4.1 shows the structure of a solar heating system like that. Part A, state the main mode of heat transfer from the sun to the absorption panel. Okay, so this time around, can I get those online to tell me what do you all think is the answer? What's the main mode of heat transfer in this question? Yep, correct. That is right. Yep. So the answer is radiation. Can you write it in? Radiation. And since it's only 1 mark and 1 word, make sure you spell the keyword correctly. Okay, next part B, suggest a color for absorption panel to enhance its function and explain your answer. So in this topic, take note, okay, the skill that I'm teaching you today is whenever they ask you to explain for this chapter, thermal energy, please try to think of answering technique again. I write shortcut AT, answering technique. If you don't know AT, you can spell out answering technique. Yep, so whenever got explain, think of answering techniques. Okay, so right now, can you flip to the previous page of notes? Can you tell me which answering technique can we use when they talk about color? Which answering technique can we use? Maybe you can tell me the title of the answering technique. Maybe can I get those physically present here to tell me? Correct, the radiation answering technique. Thank you, Zach, too. Yep, so can you just write down at the side, then later I leave it to you to do it on your own. Yep, so you just write down radiation AT, answering technique. Yep, then see whether you can fill in the blanks accurately or not. Okay, so I shall move on. Should be done copying by now, not much words. Okay, so moving on, part C. They said that explain why styrofoam is used as a backing of the absorption panel. So when you see styrofoam and explain means you need to use answering technique again, right? So in this case, can you tell me which answering technique can we use? Can you tell me the title of the answering technique? Louder a bit, cannot hear. Correct, but the conduction one is which one? The good or the poor, or is it in molecular terms? Poor conductor, correct. So later you just fill in the blanks on your own. Okay, the poor conductor answering technique. So what is the starting that you should write? How do you start off the sentence? How to start off the sentence? So you must mention about trapped air. So don't immediately go into styrofoam is a poor conductor. That's wrong. So first you must tell me that styrofoam traps air. Then air is a poor conductor. Okay. So a lot of students tend to lose the 1 mark because they never mention about styrofoam trap air. Yeah. So please don't be one of your friends that will lose mark. Okay, since you came for the lesson today. Okay, then moving on to part D, describe how a convection current is formed in the solar heating system to heat up the contents of the hot water tank. Oh, this is so obvious. So how to answer this question? Very obvious, right? How to answer? What is it? Use the convection answering technique. So you see, actually, this whole page, right, can get full marks one, right? Even though how many marks? This page is it's 6 marks question. So the whole 6 marks actually can get full marks if you study the answering technique. Okay, so I'll leave it to you to try it out on your own later. Okay, so I shall move on. Should be done copying the hints by now, right? Okay, so I shall move on to the next page. Okay, so moving on to the next chapter, thermal properties of matter. Okay, so for thermal properties of matter, mainly there is this two confusing concept on heat capacity and specific heat capacity. So how do you distinguish these two? Okay, so mainly is that you talk about maybe something that you are more familiar with, maybe water bottle capacity. Water bottle capacity, you all know, right? If my bottle is 500 ml, means that it can contain 500 ml of water before it overflows, correct? So same for heat capacity also, it means that it's the amount of heat that they can take in before, not that it overflow. Water can overflow, but we don't say heat overflow. So it's more of the amount of heat you can take in before the temperature go up. Yeah, so that means it's the amount of thermal energy that you can take in before there is a raise in temperature. So that's heat capacity. Okay, so generally is that for heat capacity, there's another version which has the word specific. So the key point about specific is just that it's unit mass. Whenever in physics, you see the word unit, right? Unit always means divided by. Something like, example, if you talk about maybe the formula of density is mass over volume. So actually, if I ask you what is the definition of density, you can tell me that density is defined as the mass per unit volume. Because per unit means divided by. And by the way, just a quick recap. Density, how you remember the formula? You can go by this. Can you see the M and B makes up a heart shape? So then when it makes up the heart shape, then you have a line across it. So it's like, piang. So I'll call it as density is the broken heart shape. So that's a way to remember the formula. Okay, so then next is that for heat capacity over here, because they say the word divided by, but if you look at the formula here, where got divide? I don't see any divide or fraction. What's going on? It's because you need to make heat capacity, small letter c, to be the subject. So if I make c to be the subject, means the m and liter, I need to divide it away. So that means it will be q equals to m change in liter. So then this time around have the unit mass already, because there is the divide by mass. Okay. Okay, then next is for specific heat capacity, this is the formula. For heat capacity, cause don't have divided by mass, so that's why the formula is just big C, let me draw big enough, equals to Q over change in liter. So don't have the letter M. Then next, sometimes my student will be confused, how to remember, big C or small c, just all C, then how to remember, is it specific or not specific, big or small letter? Okay, so how to remember, the tip is, if you look at the formula, do you realize this one, you divide by two things, M and liter. This one, you only divide by one thing, right? So in math, if you divide by two things, will the number be bigger or smaller? It will be smaller number, right? That's why you put a smaller C. But this one, you only divide by one number. It means overall, my number is bigger, right? Then you put a bigger C. So that's how you can remember. So don't need to memorize by heart, because it makes sense. Yeah. Okay, so then next it would be that the units of all the quantities here. So need to know that Q over here is thermal energy. So thermal energy, it will always be, energy is always in joules. So actually all energy, in the chapter of the work energy power, energy is letter E. But only for thermal, right, you can change to letter Q instead. So that means Q and E are interreplaceable. Yeah, so sometimes you want to write E also, actually is also acceptable. Okay, then next is the triangle theta. It will be the change in temperature. So the change in temperature in this topic, we accept both the SI unit Kelvin or degree Celsius. Both are acceptable. Okay, so then one of the very common misconception, can you write down this common misconception? So please don't make this mistake that your friends might be making. Yeah, is that sometimes question were to ask you, say that like I have an object that is maybe like maybe it's from 0 degrees Celsius, I boil it to become 100 degrees Celsius. So then the common misconception is that people, when they do the change in temperature, they say that the change in temperature is like what? Oh, it's 100 plus, because if you want to do it SI unit, it should be plus 273. So they sub in as change in temperature is 373 Kelvin when you change from freezing point to like boiling point. This is incorrect. Why? Because when you look at 0 degrees Celsius to 100 degrees Celsius, if you convert to Kelvin, 0 degrees Celsius is how many Kelvin? 273, right? Then if it's 100 degrees Celsius, I mentioned here, is 373. So you compare. Degrees Celsius is a change of 100. Over here, how much is the change? The change is also 100. So take note, okay, because don't think as because degrees Celsius change to Kelvin is always plus 273. The answer is not a difference of 273, okay? The difference is still the same. That means if you want to interchange from Kelvin to degrees Celsius, when you look at change in temperature, you don't need to care the sign. Yep, actually the answer is the same. It's still 100. Okay, so be careful that even in Kelvin, it is still 100. Yeah, so don't get tricked. So that's why I put a cross over here. Because a lot of students write as this way. They thought that the change in temperature is 373. And that's wrong already. The change in temperature from freezing to boiling is only 100 Kelvin. Okay, only 100 Kelvin. So the correct answer is the change in temperature is 100 Kelvin. Yeah, so make sure you write it down, okay? Then don't make this mistake. Okay, so yep, so that's this part. Then lastly, it will be the units for the letter C. So this one you just follow. This is joules divided by Kelvin. That's why this one, it will be the heat capacity formula is joules divided by Kelvin. Yep, so you can write as joules per Kelvin, or you want to write JK minus 1 also can. Or you can write as joules per degree Celsius, because it's joules divided by degree Celsius, or J degree Celsius minus 1. By the way, can you use a correction tape and can you erase it? Actually, there's no need to include the bracket. Yeah, can you use a correction tape? And then can you help me to remove all the brackets for the unit? Yeah, so right side also, right side. Can you also remove the bracket on the right side? Left and right, okay? All the brackets, you remove them. Don't need bracket. Okay, then the next one here for specific heat capacity. Specific heat capacity, the unit also, you just follow the formula. Yep, so for this formula here, it will be that we just check numerator is joules. So joules divide by what thing? Divide by kg. So kg minus 1 divide by temperature. Temperature can be Kelvin or it can be degree Celsius. So the unit also don't need to memorize lah. You can actually deduce from the formula. But that's only if you remember the formula, okay? Okay, then next thing to take note, very important. Over here, you look at definition. They say unit mass. But look at the bottom. Huh? Independent of mass? That means does not depend on mass. So what's going on? Like definition got mass leh. Then why you say here don't need to include mass? Then here got divide by mass what? So what's going on? Okay, so I highlighted in the same color, blue color. Yep, the reason is because, you know, in math, like whenever you subtract and you divide, means like you are trying to get rid. So that's why in this case, if you divide, means you are getting rid. Yeah, that's why it is independent of mass. Yep, that means for C over here is depend on mass. That's why if you look at the formula here, the big C over here, you realize is that mass is taken into account. It's mass times something. That means heat capacity depends on mass. Okay, that's why you see big capital C is equal to mass times something. That means the small letter C, it doesn't depend on mass. Something like, I would say, something like W equals mg formula. So, you know, in W equals to mg, we will say that weight is dependent on the location, correct? Because depend on gravitational pull. Then we say that mass is like independent of mass. Sorry, independent of G, independent. But then you see, if I were to do calculation, if I ask you, so how to calculate mass? Mass is W over G, right? So do you get it's kind of similar like this, the over M, this over G. Yeah, so that means although mass, we say that, yeah, mass is independent of the gravitational pull. Like on moon or on earth, the mass is the same. But calculation-wise, there is the letter G. So it's like, you'll get what I'm trying to say, like the way that, that's why for specific heat capacity, yep, so it is actually independent of mass, even though there is a divide sign. Okay, similar to like this, even though there's a divide by G, but mass is independent of G. Because after all, divide means you get rid lah. Yep. If not, you can use this formula to understand that big C, you see, you actually take into account the mass and the specific heat capacity of the material. Okay, then lastly, so why did they mention that depend on material? The reason is because generally, let me see where to write. A bit no space. Okay, okay, I'll space on the left side here. So need to know that generally is that a material that is considered to be high heat capacity or high specific heat capacity, they are actually poor conductors of heat. Yeah, so for example, like we talk about maybe rubber, plastic, wood. Like if you put a pot of very hot soup onto like maybe something that's like plastic or wooden table, do you realize the table like doesn't get as hot as the soup? Like when you touch the table, you won't like burn yourself, right? But you touch the pot of soup, you will burn yourself, right? Why? Because for the wood, plastic, rubber, they have very high heat capacity. That means their capacity is very big. They can take in a lot of heat before there is a raise in 1 degree Celsius or 1 Kelvin. Yeah, so that's why it's poor thermal conductors are high heat capacity. As compared to thermal conductors. Thermal conductors like metals, they will be poor, they will be low heat capacity. Cause like metals, once I take in a little bit of heat, I'll become very hot now. That means I only have a very small capacity. I can only take in a little bit of heat, then my temperature raise up by 1 degree Celsius already. Yep, so that's why we would say that good thermal conductors like metals, yep, they have low heat capacity. Yep, so that's why yeah, it depends on material. Okay, so I shall move on. This formula also need to know. Okay, then that's already all for this section here. I take it that you should be done copying by now. So if you are not done copying still, you take a screenshot. I'm going to move on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so then for the next section over here will be the latent heat. Yep, so need to know that there are 2 types, latent heat of fusion and latent heat of vaporization. So for latent heat of fusion, take note that in definition, right, it has to be strictly from solid to liquid only. But in calculation, right, it can be solid to liquid or liquid to gas. Sorry, liquid to solid. So if it's calculation, right, you can write both ways. I write down for both specific and not specific. Yeah. So if question were to say like freezing, you can use specific latent heat of fusion formula, can. But definition, only one way. Why? Because as the name suggests, fusion. Example, if I say that I have a fusion of cuisine, maybe I have a fusion of maybe Western and Korean food, for example. So if it's a fusion, means two things come together, correct? Two individual ones come together. Isn't it like two ice cubes separate? Then now when they melt, the water will mix together. Yeah, so that's why fusion is always from solid become liquid because they fuse together. So definition only one way. So definition cannot write liquid to solid, cannot. So I write down over here, cannot write from liquid to solid. Definition, I think you should know lah. Definition always must memorize, right? Then must be word for word. So you follow. Yep. So how to remember? You go by the definition of fusion. Fusion means that like food, food fused together. Then likewise also for vaporization. So for vaporization, also strictly liquid to gas. You cannot write as gas to liquid. Cannot. Because as the name suggests already, there is vaporization. TION means process, right? That means it's a process in making it vapor. And spell correctly, don't have letter U. Keyword don't spell wrongly, okay? It's not the water vapor, VAPOUR. Don't have letter U, okay? Yep, so then same thing, definition is only liquid to gas. But for calculation, can. You can be liquid to gas. You want to calculate gas to liquid also can. Either way is fine for calculation. So that means if it's condensation, you can also use the latent heat of vaporization. Can for condensation. Okay, then next. Over here, likewise as above, I'll highlight the same color as above, specific. Specific always means divided by mass. So again, same thing, you need to make the latent heat to be the formula. So if I make latent heat of fusion to be the formula, it will be Q over M. That's why you have the divide by mass. Because remember I told you that unit mass always means divided by mass. That's why divided by mass. Okay, then next it would be that need to know that for latent heat, over here is just actually just the heat law. So that's why it's just Q itself. Yeah, so it means how much heat you supply to melt it, that will be the latent heat of fusion. Okay, so latent heat is just the amount of heat. Yeah, only when got specific, you then take the amount of heat divided by the mass. That's why the unit for latent heat is just joules. This one must divide by mass. That's why kg minus 1. Okay, then lastly, need to know that LV is actually bigger than LF. Why? The reason is because in order to make it to become vapor, you need to push the particles from liquid state to become very far apart. This one you need more energy. As compared to fusion. Fusion is solid, become liquid. So it's like from regular, just become slightly irregular with a tiny bit more spacing. So you don't need that much energy because it's still very nearby. Just separate a little bit will do. As compared to vaporization, you push out a lot. Yep, so that's why vaporization number is bigger than fusion. Okay, so let me answer Zach's question. So you're asking, instead of fusion and vaporization, how does the concept of latent heat apply to solid to gas directly for sublimation process? So for sublimation process, you don't calculate, they won't give you a question on sublimation and then calculate latent heat of fusion or vaporization. No. Yeah, because all this is strictly must have liquid state, but sublimation don't have liquid state. So for sublimation and this concept, they don't work together. Yeah, so it doesn't apply. Okay, so then this chapter very big. So this chapter got extra one more page of notes, which is on evaporation. So over here, this another answering technique again. So it's like a nice template. You just follow and copy it in, then you can get 2 marks. Okay, so can you all label it in? So this is an answering technique. Like if they ask you like what's happening like during evaporation. So mainly you must tell me that the more energetic particles at the surface gains enough energy and is able to overcome the downward attractive intermolecular force. So since they are able to overcome, that's why they will be able to escape into the surrounding as gas. Yep, so how come they can escape into the surrounding as gas? Because they have higher kinetic energy. So the more energetic part over here, what is that specific type of energy? The energy is kinetic energy. The explanation here is similar. It's still there. Can you see about the what intermolecular force of attraction? Yeah, it's still the same stuff. Okay, then next, sometimes question not only ask you how does evaporation occur in molecular terms, they might also ask you how come evaporation can cause cooling. They ask you to explain in molecular terms. So if they add on cooling, then this will be another answering technique. So can you label it again? This is another answering technique. So you must mention that the more energetic molecule will escape. And when they escape, they will bring together with them the energy. That's why in the end, the leftover particles' average speed and kinetic energy decreases. Yep, so with less Ke means less temperature. Something like, if you were to boil a pot of water, you realize the water will move very vigorously, right, when it's hot. Yeah, so that's why higher temperature means higher Ke because they move faster. That's why lower Ke, that means it is cooler. Yeah, so that's why evaporation has a cooling effect. Done. So I take it that you all should be done noting down, because Minnie just highlighting should be quite fast. I shall scroll down. If you're not done, maybe you take a screenshot or you just remember where to highlight. Moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so then the next part here, this one I think you already know from school. So can you just go and study it? Yep, need to know, very commonly tested. Can you put a star? Commonly tested, so make sure you put a star. Need to be able to at least 2 lah. Yep, because sometimes they will give you 2 marks question. So memorize at least 2 of them. But of course, you need to know all of them. Because if it's in MCQ, maybe out of 4 options, 1 is wrong. You need to recognize which 3 are correct. So need to know all, but memorize 2 will do to be able to write for open-ended. Okay, then next part over here, factors affecting rate of evaporation. This one I think you should know for all of them. So this part quite easy, quite factual. So this part here, I won't go through. I'll leave it to you to study it on your own. Okay, so then now let's take a look at the practice questions at the back here. So likewise, for MCQ, I let you try on your own later. Definition, you copy from the previous page on your own later. Let's take a look at part B over here. Okay, so for part B, they said that Jisoo really likes coffee, but on a hot day, she doesn't want to drink a hot beverage. When she is served 200 cm³ of coffee at 80 degrees Celsius in a well-insulated container, she adds ice to the coffee to obtain a temperature of 30 degrees Celsius. So now they are asking you to calculate the mass of ice at 0 degrees Celsius that she add to the hot coffee and assume that most physical properties of coffee are similar to those of water. Okay, so what they are trying to say over here, right, about assuming that the properties are the same, because over here, if you notice, there's like volume, then there is like density. Yeah, so what they are trying to say is that the density of water will also be the density of coffee. Just treat them to be like similar. And so that's what they are trying to hint to you. So take the density of coffee to be similar to water. Okay, so then, so now what are we supposed to calculate? The aim of the question is to calculate the mass of ice added. Okay, so for this kind of topic, how do you go about doing it? So you should always do in terms of heat gain equals to heat loss, something like the work energy power topic. Like example, if the object come down, it will be like, the GPE, loss in GPE equal to gain in KE. Yeah, so same for here also. Loss in one energy, gain in the other energy. So in this case, it will be thermal energy loss in one thing will be thermal energy gain in another thing. Yep, so in this case, can you tell me for loss, thermal energy loss, is it coffee or is it ice that has thermal energy loss? So which one undergo thermal energy loss? Is it ice or is it coffee? Correct. Let's write it down. Yeah, write clearly so that later when the working gets messy, at least you know like what's going on. Okay, then now we need to identify the formula required. Okay, so how do you know when to use like latent heat, when to use heat capacity? So mainly it depends on, let's go back to the definition. So mainly it depends on here. For latent heat, there is no change in temperature. So can you highlight this? Latent heat, can you highlight for both sides? That latent heat has no change in temperature. Done highlighting both sides. As compared to heat capacity is got change in temperature. Can you see that? Change in temperature. Where is it? Change in temperature. Yeah, so that's how you decide when to use which. Okay, so then now if we were to go back to this question here. Okay, so over here, yep. So for this question here, so now what should we do to the coffee? So for the, wait, let me scroll. Okay, so for the coffee, did it change in state and temperature? So for coffee, it only change in temperature, right? Because the coffee, no matter what it is, whether you add ice or not, it is still liquid state. So that means only change in temperature. So which formula should we use? Should we use the heat capacity formula or should we use the latent heat formula? Which one is it? We should use the heat capacity formula. So let's put in the formula MC change in liter. So since no change in state, don't need to write the latent heat one. Okay, then next for ice. So for ice, what formula should we be using? For ice, which formula should we be using? The latent heat one or the heat capacity one? Which one should we use? I should use both. Very good. Because first, the ice need to melt. So that's fusion, because fusion is the solid and liquid state one. Yeah, so first you need to melt. Melt already, then the ice become hotter. I mean the melted ice, which is water, then become hotter. Then MC liter. Okay? Yep, like that. Okay, so now I give you some time now. Can you give it a try and sub in all the values to see whether can you get the correct answer? You give it a try. Okay, so in case you are lost, I'll recommend that you go and find out what's the mass of coffee first. So for the coffee, it would be that then they mention here volume. Then I said that density, you treat it to be the same. So density of coffee, you treat it as 1. Go and find out the mass first. Okay, then next is the change in temperature. So you have to check the coffee change in what temperature? The coffee changed from 80 to 30. Then for the ice will change from 0 to 30. Yep, so I've color coded them for you. Yep, so you just need to make sure you match correctly will do. Yep, then you are supposed to solve for M. Yep, so M is the one that you need to solve. So just leave it as M lah, because you do not know what the mass is. So for mass of ice, just leave it as M. Then solve for M. So at the end, you should tell me like M equals to how much? Yep, Z is correct. Just wondering, Zach, are you the Zach that attend my physics online subscription? Can tell, can recognize. Or because at Overmark we actually have this the like purely online tuition. So it's like only like $99. Then it's like you can attend like all subject. Yeah, so like Zach is one of the students that keep attending my physics lesson. Yeah, so if you're keen, you can sign up also. Yeah, all subjects. But no physical lesson, only online. Yeah, so got like English, humanities, yeah, like what history, social studies also have. Yeah, then math, sciences, yeah, all have also. Your answer is correct. Good. For those of you who are fast, meanwhile waiting for the rest of the class to be done, why not you try to do the earlier questions? The earlier question, we skip quite a lot of questions, right? I said you do on your own. Yeah, so while waiting, why not you go back? Sorry, can I check with you, the two of you, just now you were saying you learn light or you learn wave? Wave. Okay, then I start on wave first later. Okay. Okay, so for those online, once you are done for this question, can you click the raise hand button to let me know? Then once you finish, then I'll review the answer. Yeah, so raise hand when done. Raise hand, don't click the other symbol. Because the other symbol, they will disappear very fast. Then after you raise hand already, then go and do the earlier questions. So whenever you're not sure, you just look at the screen. I have color coded the hints for you. Oh, by the way, oh yeah, I think I need to give one more hint in case you are lost. If you are wondering like what's the specific heat capacity of coffee, because over here they say the physical properties is same as water. That means the specific heat capacity of water is also the specific heat capacity of coffee. Okay, in case you are stuck in the sea. It means like same material. Remember, material affects the heat capacity. Yeah, so if they have similar physical properties, like almost same material, then the specific heat capacity should be the same also. Then remember, once you have finished, must click the raise hand button, okay? So that I can review the answer. LF is latent heat of fusion. You can refer to the definition page for this chapter. It's at the bottom of the first page of this topic. Okay, I think I shall go through the answer now. If you still can't solve by now, I think most likely is that you are stuck. Okay, so I shall show the answer now. Okay, come, can you all check and see if your answers are correct? The answer is 91 gram or 0.091 kg. Yeah, this is the answer. Yeah, so mainly we just sub in the numbers carefully. So as mentioned, you just check the number lah. I think quite straightforward. Yeah. Anyone don't understand why the number I sub in like any of the number here? If you don't understand, you let me know, can then I explain to you. Because I think it's very obvious lah. Like you there you have to follow M, LF, C, then deta. Then this M, then this is like C, and this is deta. Yeah, so just match. Oh. Maybe I draw arrow. Yep, like that. Nice. Okay, so depending on what your school says, if your school says to follow the SF in the question, then in this case, the numbers are all 3 or 2 SF, you follow the least SF. So you write 2 SF. But if your school teacher say, oh, everything just do 3 SF, you write in 3 SF. Yeah, no problem. Okay, so as you are copying the correction, let me now give the differentiated instruction. So for those of you whose school only tests on thermal topics, can you now use the remaining time to go and finish up all the in-front questions that I told you to do on your own? Then at the end of the lesson, I'll give you the answer key. Then you then check your answer. Okay? Then for those of you who learn as in who are tested on general wave properties and light, you follow me through because I'm going to move on to wave first, then light. Okay? Yep. Okay, so just to double check, like for those online, for those of you who school cover on wave and light, maybe can you type it in the Zoom chat to let me know, does your school cover like both? Or does your school only cover wave? Or your school only cover light? So maybe can you type it in the chat? Is it both wave only or light only? Both wave or light only? Yep, so can you type it in the chat? Then I will do, depending on wave or light, I will do that topic that most school do first. Yep, so we go by democracy lah, because Singapore is a democratic country. Yeah, so although you can't vote for the presidential election, but at least I let you vote in the class here. Yep. So you let me know what topics you are tested for end of year. Yep. Then if you don't tell me, then too bad lah. Then I don't know what topic you are tested. Then I'll just choose based on what those who tell me. Yep. So can you tell me now in the Zoom chat? Okay, so based on those of you who told me, kind of quite balanced. So I think I will cover just maybe like a bit of you more in terms of wave. I think I'll cover wave first, then I cover light. Should be able to have enough time to cover both. Okay, so wait, no, this is my answer key version. Let me clear away first. Oh, wait. Before I move on, just want to double check for those online. Are you done with correction? If not done, maybe you want to like take a screenshot because I about to change the screen too soon. Okay, so I change the screen in 3 seconds. If you need screenshot, you take a screenshot of it. 3, 2, 1. Okay, moving on. Okay, let me remove my answer key. Okay, so yep, can you all do, so those who only need thermal, you do your thermal worksheet now. I start off with waves. Okay, so for waves over here, same thing, I just go through the key point. I don't want to go through the entire chapter. Okay, so for wave, mainly need the more chim question that I think usually students tend to be like, don't understand, confused with is like when they suddenly change the depth. Yeah, this is the more chim kind of question that schools like increasing trend like to test about this kind of question. So whenever you have shallow and deep water, what will happen to the speed, frequency, and wavelength? So need to know that okay, this one you can actually use like your knowledge of general knowledge, like shallow water is like swimming pool water. Then deep water will be like in the ocean, in the sea out there, right? Yep. So generally is that for speed, how do you tell? Something like, okay, for example, if I use an analogy of car, example, touch wood, if a car were to like bang onto this person, then if the car drives and then bang onto this person at a low speed, do you think the person will lose consciousness? The person won't lose consciousness, right? And most the person can even maybe dodge or maybe just a bit of an abrasion or blue-black or bleed a little bit, but not to the extent of like hospitalized and or unconscious, that kind. Yeah, so slow, usually still conscious. Okay. But then if the car was super high speed, like 100 km/h, I think that kind, you know, like, it's gone already. Like, the person is like unconscious already, right? Yeah, so same for water wave also. If it's like shallow water like swimming pool wave, okay, so let's write it in. For example, swimming pool wave. Yeah, so for swimming pool wave, it will be that the person, when you have water wave hitting the person most likely still conscious, right? Yeah, because the person is like still like, I can feel the wave lah, but then so like it doesn't make me like unconscious. So same as lower speed vehicles, lower speed vehicles also like hit the person still conscious. As compared to deeper water like sea wave, if I throw you maybe in a cruise, then I throw you out into the sea, I think any water wave hit you, I think you should be like either swallowed by the water, if not like lose consciousness already. Yeah, it's because deeper water, same as fast car, yep, it's like their speed is higher. That's why it will cause the person to lose consciousness. Yep, so that's why like for sea wave, ocean waves, yep, it will be higher speed. Okay, then next is frequency will always be the same. So usually question will to ask you like any situation, then they ask you what happened to the frequency, just write same lah. 99% of the time your answer is correct, except when the person sing at different pitch. That's chapter of sound already lah. Yeah, but usually all cases usually the frequency is the same. So when you write same, it's very safe because frequency actually depends on the source. Because by right, for an experiment, you should know that you should only have one change variable. If you change the depth, you shouldn't be changing the frequency of you dipping in and out this like bar. Usually it's like a bar, then with a stick, right? You just dip in and out of the water surface to create all this like water ripples wave. Yeah, so by right, the frequency that you dip the rod in and out, it should be the same frequency because you should only have one change variable. Yeah, that's why frequency is the same. Then for wavelength, same thing. Swimming pool, usually it's water ripples, right? So you see the wave, they are very close together. So we cannot see. Let me lower it. Yep, so for water ripples in swimming pool, the wavelength, it will be the crest to the crest. But then for sea wave is usually one wave come already, then later another wave, then come again, right? Yeah, so that means the crest to crest is further apart. That means the length of the wave, called wavelength, length of the wavelength, it will be longer. Yep, so that's why deep water, it will be longer. That's why, as you can see, the right side, the lines are longer, the left side, the lines are shorter. Usually school at most test until like that lah. Unless your school is like so evil, like try to like test until super extremely difficult, or maybe trying to make a super difficult question to maybe differentiate A1 versus A2 students, then sometimes they might ask you, they draw left side, can you draw right side? So then the right side, the line should like bend like that upwards, or should the line like maybe bend, like is it downwards? Yeah, so like which way should we go, right? So you see this line is going up, this line going down. So how do you know? This one very rarely tested. I just go through just in case. Okay, so meaning what you do is, this is the surface, right? You just use what you know from the chapter of light. All of you do learn light at least in lower sec. So what you do is, sorry, I can't draw straight line on the screen. Okay, you draw in the normal line. Okay, so for the surface here, you draw in a 90-degree line normal. Okay, so this is meant to be a straight line. Sorry, I can't draw straight line. So can all of you now draw a straight line, normal line? Yep, that's 90-degree to this dotted line. Yeah, draw in the normal. You know, normal is like 90-degree to the surface, right? Yeah, so you draw in a 90-degree line, which is the normal. Okay, so what happened is that, can you see that for shallower waters, the number are all smaller, right? The V is smaller, the lambda smaller, everything is smaller. But then for deep water, everything is bigger speed, bigger wavelength, everything is bigger. So then in this case, the angles also the same. This is the angle of incidence, right? Because angle of incidence is between the ray and the normal. Then for this one, this is the refracted ray. So it's like the angle of refraction will always be between the ray and the normal. Okay, so remember, always between the ray and the normal. So that's why yellow shallow water, angle smaller. Deeper water, angle bigger. Then you do as per normal lah. Yep. So you just draw the light ray on opposite side of the normal. So one is like below the normal. So the other line should be above the normal. So it should go up lah, not come down. Because if you come down, then you realize that this line is like both below the normal. Cannot. Because like, example, if you have like water and air, light, when they bend, they must go to the other side, right? You cannot draw them to come this side, right? Yeah, so the light ray must be on opposite side of the normal. There. So the normal is here. If one is below the dotted line, the other one should be above the dotted line. So this one below is incorrect. Yep. Then after you draw the line already, then you realize that this line and the wave front are 90 degree. So after you draw this line, you draw a 90-degree wave front. So this will be your wave pattern. So that's how you draw it lah. But I hope this kind of question don't come out because this is like a bit too difficult already. Yeah. Okay, so I shall move on. I take it that you all should be done copying. If you are not done annotating everything, maybe you take a screenshot. Moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so for the next part over here, so sometimes question will ask you like, I show you the original graph. The original graph is the black one. Then now, can you draw for me 1/4 period later how to draw the wave? Or half a period later how to draw? Or 3/4 later how to draw? So what you do is first, based on the original, you go and chop out the graph into 4 regions first. So that's why first for the black color part, okay, so maybe it's the same. Okay, so you don't need to draw again. I'm just repeating. Okay, so first you start off with the black color line first, which is the original. Okay, so I draw the original wave first. Something like that. Sorry, I can't draw very evenly because I'm drawing on the TV. Okay, so first I will chop up, this is one wave, right? I chop it into half, then I further chop it into another half. Okay, so then next is, if I say half a period later, that means instead of my wave going up at the start, I go up half a period later, because this half, correct? Because the graph, I chop it into half. Then over here is that I chop it into 1/4. Then over here is that I chop it into 3/4. Yep, then here it will be back to one whole period again. Yep, so in this case, if I say half a period later, how do you draw the wave? Since my wave is a sine curve and it's going up first, that means at half a period here, I'll draw a sine curve going up first. Yep, so then do you realize this is directly mirror image of the black one? You just flip up to down. Yeah, so that's why you just draw the mirror image. So this will be how you draw for half a period later. Okay? Okay, then next one, if I were to ask you, can you draw 1/4 a period later? So same thing, where's the 1/4 mark? 1/4 mark is here. Since my curve is always going up, sine curve, I also draw go up. Yeah, then just continue to draw. Yep, so then you just continue to draw. Yep, and all, yep, so then in the end, oops, sorry, I can't draw very well. Okay, then in this case, yep, so then in the end, the graph became cosine graph instead. Okay, then next, for 3/4, remember, when 1.5, they are mirror image. So that means whenever it's half a difference, it's always mirror image. So that means 1/4 and 3/4 also half a difference. It will also be mirror image. So that means to draw the green one is just the reflection of the blue one. So can you see the green and the blue? They are just directly reflected. Okay, you just flip about the x-axis. Yeah, so this is how you draw the wave at different period later. So then sometimes it's not only like half, 1/4, 3/4. Sometimes it can be like 2.5 or like 1 and 1/4. Then how you draw? Because for 1 or 2 period, right, they will always be the same. Because if it's 1 period later, isn't it here? Then I draw the graph go up first. Isn't it exactly the same as the black graph? So that's why whenever it's like on the number 1 or 2 or 3 period, the whole number in front, you can just ignore. Yeah, you just look at the fraction. Because the fraction will really change the position of your graph. Yeah, so that's how you draw it. Okay, then another question over here. This is super common. This one like must know. So let's put a star. This is very commonly tested. Commonly tested. Yep. So whenever they ask you, can you find out what's the movement of the particle at the next instant? Given that this wave move towards the right. So what you need to do is you always draw the wave like towards the right a little bit to know that the immediate next moment, like how the wave is. So that's why you shift the wave to the right a bit. So this is like the next moment, of course they said the wave move to the right. Then you take a dotted line to draw a dotted line vertically across the point of interest. So the question asking you P, Q, or S. You draw a dotted line for P, Q, or S. So after you draw the dotted line, then you compare the original point and the new point. So the original point, like Q, is over here. Where is the new point Q? The new point Q will be where the dotted line and your new wave is. Okay, in case you lost there, you don't know what I'm talking about, I draw step by step, right? Because this one is like everything drawn in. So maybe I have like that. Okay, so my P is like somewhere here, right? Then Q is like, no, Q is like here. Okay, so then what you do, wait, okay, maybe let me draw everything in first. R is like here. Then my S is like somewhere here. Okay, so what I need to do first step is you just draw a wave slightly to the right a little bit, because they said that the wave move towards the right. Okay, wait, cannot really see. Let me change color. Maybe I do red. So you just draw a wave that's slightly towards the right. Something like that lah. Okay, then next is what you do is you draw a dotted line that cuts across your original P, Q, or S. That means I cut across P, I cut across Q. Is my line straight? I cannot tell because I'm sitting very sideways to the TV. I hope my line is straight. Somewhere, something like that. Okay, so then in that case, after you've drawn in a vertical line that cuts through P, Q, or S, then what you do is you find where's the new point of intersection between the dotted line and the red color wave. So the new point of intersection, it will be still here. The new point of intersection will be here. New point of intersection is here. New point of intersection is here. Yep, so you go and find out where's the new point of intersection between the red line and the dotted line. Okay, red line and dotted line. Then now you check out, so how did the particle move? P is still around the same place. So we will say P is stationary. Q is from here. Now it becomes here. This is the new position of Q. That means Q move upwards. Then for R from here, now it becomes here. This is the new position of R. So R actually moved downwards. Then for S, this is the OS. This is the new S. So the S actually moved upwards. Yeah, that's why it's upwards. So this is a neater drawing of it. Yeah, so you just based on where the new position is. Because after all, although the wave moves towards the right, particles don't move together with it. Remember? It is only the energy that travel together with the wave. The particle don't travel together with the wave. The particle only oscillate about their equilibrium position. And then if it's transverse wave, they will just keep oscillating perpendicular to the wave. That's why if the wave move right, the particle just move up, down. Okay? Yeah, so that's why the answer can only be up and down. Cannot be left or right. Yeah, because particle do not travel together with the wave. Because if the particle move together with the wave, then jialat already. Like example, swimming pool. If I jump into the swimming pool, then the wave move away, right? If the wave move away from me, and if the water particle also move away from me, then what happens? When I jump into the pool, after a while, surrounding me, the water level will go down. Then the other side of the swimming pool, the level water go up. Cannot be, right? Yeah, that's why the water particles don't move together with the wave when I jump into a swimming pool. Okay? So the particles around me just oscillate. They don't move together with the wave. That's why around me still got a lot of water after I jump in. Done. Okay, so I shall move on. I take it that I don't need to copy this because what I've just written here is all shown neater on the left side. Okay, so you just note this down. Particle do not travel with the wave, will do. Okay, so I shall move on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so for the questions here, I let you try out on your own. Yep, then the calculation question here seems to be not too difficult. Maybe we just quickly do it. Yeah, this question you try now. Of course, not difficult. You try already, then I go through the answer. Yeah, so you do it now. Yep, do part A and B now. So I will review the answer based on those who are physically present here, done. Yeah, because those online, some of y'all don't need to with, so I cannot gauge. Yeah. So once those physically present, done, then I'll review the answer. Yep. So finish up part A and B now. Yes, Zach, your answer is correct. Good. Then you can move on to do the earlier thermal questions while waiting. Yeah, so any of you who are fast, after you finish this wave question, just move on to do the thermal questions. Let me just go around to see for those who are present here. Yeah, I see that some of you are stuck in part A. So anyways, for part A, you need to use the general wave properties. There is this formula, right? Do you know what's the formula? V equals to, no, V equals to F lambda. Okay, so let me write it down. So I need to use this to solve. V equals to F lambda. You know what each of them represent, right? Can I? Okay, then I don't need to explain that. It's here is length. Period is not one over length. If the x axis shows still coming, then you are then wrong. So for part B, you all have to use the skill that I was teaching just now, the what? Half a period later, 1/4 period later. Yeah, so with 0.1 second is how many period later? And then you draw the graph accordingly. Then once you draw the graph accordingly, then you can sort of locate where position X is already. Okay, so cause of time constraint, I think I will review the answer already. Okay, so come, let's check your answer and see if it's correct. So this is the answer, 0.4 seconds. Okay, so for 0.4 seconds compared to 0.1 second, do you realize that 0.1 second is actually 1/4 a period? Because one period is 0.4. 0.1 is 1/4. So that means you draw the wave 1/4 a period later. So that means same thing, the whole wave, you chop it into 4 parts. So I chop it into, oh, not accurate. Okay, so what happened is that for your particle, this time round, you start from on top, come down. So 1/4 period later, isn't it this line over here? This is 1/4. You start from here, come down. Let's draw the wave. Yep, so when you draw the wave, then do you realize that at point P over here, the point P is actually should be at the bottom? Yep, so that's why you put a cross at the bottom here. So that's how you deduce. Okay, yep, done. Okay, so I shall now be moving on to the chapter of light. So if you are not done with the correction, can you take a screenshot? Then I'll be moving on already in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so moving on to the next chapter on light. Okay, so for those who don't need light, can you just continue to do like the other questions that are not done? Yep, then now I shall go through light. Okay, so for the chapter of light, ray diagram, I think hopefully it should be okay. Key point is that the mirror side, it should be, so those who need the chapter of light, make sure you listen up, light. Okay, so for the right side here is mirror. Mirror is always virtual image. You draw it as dotted line. Real world side must always have solid lines and the light must point into the eye. You are not superhero, okay? You cannot shoot out laser beam, okay? So the arrow cannot come out from your eye. It should go into your eye. And that for the light ray drawing, be it reflection or refraction, the drawing is the same. So for reflection, it would be that step 1, you draw image, equal distance, and then dotted line. Step 2, you connect from the image to the eye. So how do you know when to draw 2 light ray, when to draw 1 light ray? It depends on whether is it giving you eyelid or 1 dot. If it's 2 eyelid, then got 2 eyelid, you draw 2 light ray. Only 1 dot, you draw 1 light ray. Okay, so 1 dot, 1 light ray. 2 eyelid, 2 light rays. Then after you're done connecting from the image to the eye, you connect from the object to this point of intersection here. Because can you see this line and the mirror, they intersect over here. So you connect from the object to the point of intersection. For refraction drawing, is the same also. For refraction, like water, and then this air. So inside is water. Water, outside is air. So in this case, same thing also. Step 1, always draw image. And that things in water always appear shallower. Yeah, so that's why what you do is you draw it shallower. And I'll recommend that you draw much shallower better. Because when it's much, much shallower, the lines won't overlap too close. Okay, then next is that step 1, draw image. Step 2, isn't it the same? You look at the previous one. Step 2, connect from image to eye. Over here also, connect from image to eye. So you connect from the image to the eye. But then the eyes always think that light travel in straight line. So you draw straight lines. Okay, then third is you connect from the object to the point of intersection. It's the same again, you see? Yeah, so actually reflect and refract is the same. I don't know why school teacher every time teach until like very different drawing like that. Okay, so for object is here, you connect, sorry, object is here. Just now, where did they intersect? They intersect with the water surface over here. So connect from the object to the point of intersection. Yep, then done already lor. Then arrow again into the eye. Don't shoot out laser beam. Okay, then let me continue on with reflection first. So next part over here is a kind of question. Try to remember, okay? Sometimes if you cannot solve, think of similar triangles. Can you see that over here, there's a triangle? Can you highlight it? Then over here, there's another triangle. Yeah, so sometimes can think of similar triangles to solve besides angles, sine, cosine, theta. Yeah. Okay, then moving on to refraction. So refraction, actually there's this mnemonic to help you to remember, like it's bend towards or bend away. You go by this mnemonic called FAST, F-A-S-T. What does it mean? Fast means that light will be faster when it travels away from the normal. Light will be slower when it travels towards normal. Yep, so this is like some tips and tricks that we teach at tuition to help you all remember. Yep, so how does this fast applies is mainly like you see if you are at a less crowded place, you can run very fast, right? Because not crowded, you can run very fast. But then if you're in a crowded place, you'll move slower. So that means if faster place, usually is the place is like less densely populated. That's why you can run very fast. It will be slow. You can only move inch and inch behind the crowd when you are in a more densely populated place with people. So same for particle also. If the particle is in, if the light is in a material that is more dense, it will travel slower. So when you go to more dense, will be towards. Less dense is away. So this is how you can remember lah. Yeah, so in case like sometimes you blank out in exam, I can think of FAST to decide towards or away. Yep, then yeah, I think you should know how to draw the diagram. Okay, so moving on. So next part over here, it would be that you need to know about the total internal reflection thing. So generally is that when your light ray is traveling straight through, that means if you were to draw in a normal and the ray, if you realize they are stuck together, if there is no angle of incidence between them, that means there is no refraction. Because no angle I, how to even have angle R? Then now you open a bit, yep, got refraction. You open up even more, then the line will just keep on follow. That means they will turn together. That means the bigger the I, the bigger the R. This is the R. Yep. So as they mentioned over here, as I increases, actually angle of refraction also increases. Yep. So then as angle of refraction increase, then in the end, it will increase until like go all the way in. So when it is equal to C, we say that it travels along the glass air boundary. But if it goes all the way in, that will be total internal reflection. So total internal reflection takes place when the angle is super huge. Yep, then take note that how do you draw on the normal, like maybe like at this point here, how to draw the normal? The normal for the curvature parts is always the radius of a circle. Okay? Then there are some work examples at the bottom. I leave it to you to go and read up on your own because it's already drawn out already. Yep, then these are the refractive index formula. So refractive index, take note, when you calculate, n must always be bigger than 1. If your n smaller than 1 means got careless mistake. You need to double check your working. Why? Because the refractive index of vacuum is 1. And that refractive index is proportional to the density of the materials. So that means for all materials, there is no material less dense than vacuum, right? Vacuum is nothing really. So since there's no material less dense than vacuum, that means no material can have n smaller than vacuum. So that's why it's definitely that it has to be 1. It's the smallest. Okay, for no matter what material, it should be bigger than 1. And then n don't have a unit. And then n is also unique to each material. So this material is this refractive index, no matter you change the shape or the thickness. Yep. And then yep, so greater refraction means usually if the lines bend a lot, right, that means they have greater density difference. And then usually it's because if one very, very less dense, one very, very high density, that means yeah, the speed will like slow down or increase a lot. Then it will result in greater refractive index because n is C over V. If the two numbers differ a lot, then your n will be bigger. And then you can link it to the critical angle value here. If n is bigger, that means your C will be smaller. So if your C is so small, like maybe 2 degrees only, that means very likely whatever angle light I shine is most likely to undergo TIR. Yeah. Okay, then then the next part over here on lens. So for lens, just one key point is that whenever you look at the ray diagram, make sure that horizontal line must become diagonal line that cuts through F. Okay, yeah, and that for the when you look at the words correct inverted, make sure it's both vertically and laterally inverted. Okay, it's both. Yep. And that usually if you look at the table, I don't have the table here. You look at your notes. Whenever the object and image, they will move together. That means like if object move to the right, image also move to the right. Object move left, image also move to the left. And when they move same direction but different amount. Yep, it's different amount. Yep, then generally that's about it lah. Yep, so got what example you can read it on your own. Then there are practice questions, you can give it a try. Okay, so now yep, so then yeah, then that's already all for today. Okay, so let me now show you the wait up. Okay, so yeah, so yep, that's all for today. So maybe before your head off, just like maybe can I get some feedback from you all so that we can make the sessions like the upcoming sessions over the next few days to be better. Yeah, anyways, if any of you interested to sign up for OVERMUGGED tuition, like maybe in future you find that like after your result out, or now that you find that you need a tuition, you confirm want to sign up for tuition next year. Yep. So actually if you sign up with us this month before the result is out, that's early bird. Yeah, so we will actually give you a lot of benefits. Yeah. But then if you want to wait for result out, then sign up also can. Then by then, you just let us know in October after your result is out, and we will arrange for you to attend free trial lessons so that you can try out like the lessons in the classroom here to see how it goes. And then like the teacher of that location that you chose, like whether you like the teacher's teaching vibe and style. Yep. Then if you feel that yes, I like the teacher's teaching style, then you can actually sign up. Then we will start the group tuition. Depending on teachers, some teachers start earlier a bit, some teachers start later a bit. Yeah, like that. Okay, so maybe can you scan the QR code and give us some feedback so that we can know on how to make the lessons better for you? Yeah. Then after you all fill in the feedback form, I will be giving you the answer key. Yeah. So you fill in the form first. Oh, Agnes, you can actually access the lesson. Oh wait, first day notes. First day lesson material. Okay, wait. Let me try find. Or maybe you can stay back a while if I can't find in time. Hold on. First lesson for physics. Let me find. Okay, I found it. Yep. So I will give you the answer key also. The recording of the lessons will be uploaded soon, but it's they don't upload for all centers because our lesson 1 of physics we teach at 3 outlets so it's only one of the teachers' recording will be uploaded on the YouTube. Yeah. But we are doing the same worksheet still. Yeah, so people, if you appreciate our time to give you such free lessons, so hope that you can also contribute a bit of your time to give us your feedback. Okay, so I shall now show you the answer key of the today's worksheet. Yep, so you can scan. Okay, so I think I will end off the lesson here. So hope that you all have managed to like clarify your concepts better and then like pick up some misconception that actually you had and then get a better view today. Yep, so then you download the answer key from this QR code on the left here. Yep, then if you have any questions, you can stay back behind to ask me. Yeah, if not, you're free to go off already. Yep, so then that's all for today then. Thank you. Bye-bye.